Good afternoon. Can you hear me? Students, can you hear my voice?
Yes, ma'am.
Okay.
Yes, ma'am.
Yeah, thank you. Okay. So I think in the previous class, stopped with the slide, we were discussing about isolated IO as well as memory mapped IO. Because this is very important concept and a separate 5 mark question, they'll be asking this. So they'll be asking to write about isolated versus memory mapped IO, and this question is being frequently asked in 5 mark. Okay. So if they ask you to write about this isolated versus memory mapped IO, I have already told you that we have three different types of bus construction. Three different types of bus construction. Like you have common bus with common control lines. You have common bus with separate read and write control lines. And you have a separate bus, one for memory and one for IO. Okay. So these are the three variations. Just I'm summarizing what we have seen in the last class. Yes, and for everything, I think I have given you the diagram also between isolated versus memory mapped IO. In the first case, if you are using common bus to transfer the information between CPU to memory and between CPU to IO, you can use a common bus. So you know what is a bus? Bus is nothing but group of communication lines. Yes, you have data line, address line, and control line. What is control line? You have two different types of control line. That is one line for reading and the line for writing. So it is a read control line and write control line, right? And if it is a common bus, I think I have shown you the architecture for common bus also, how a common bus is being employed between CPU to IO and CPU to memory. Okay, now let us see about isolated IO. I have a separate diagram for you just to differentiate. So when it is asked in 5 mark question, then you have to put separate architecture for everything. Okay, so this particular diagram shows you about the isolated. Isolated அப்படினாலே தனியா இருக்குன்னு அர்த்தம். Isolated அப்படினாலே தனின்னு அர்த்தம். Okay, fine. So see, here your data and address lines are common. Your data and address lines are common. See, here there is a CPU. I'll highlight it for you. Listen. Kana, please note down the architecture in your notebook. It is very, very important. Isolated IO, you have a CPU. CPU has to communicate with memory. At the same time, CPU has to communicate with the IO devices. At the time, I told you that I can connect to n number of IO devices. Here, two IO devices are given. Two different IO devices are given. And here the port, here they have mentioned it as port. It is nothing but the connection. நம்ம போர்ட்னா நம்ம லேப்டாப்ல நம்ம கனெக்ட் பண்றோம் இல்லையா, அந்த ஓட்ட ஓட்டையா இருக்கிற இடத்துல நம்ம போய் சொருகுறோம்ல, that is called the port over here. And in that place you can write as interface. You can write it as interface because I told you that CPU cannot directly communicate with IO devices. Why? Because there is a difference between CPU and IO. CPU is fast, your IO devices are very slow. CPU is an electronic device, your IO devices are electromechanical or electromagnetic. And the data format that too varies between CPU and IO devices. And this is the reason why we cannot connect CPU directly with the IO devices. And that is why for using interfaces, that is one interface for every IO device. Suppose, say for example, if I connect 4 IO devices, then I need 4 interfaces, then I need 4 different ports. Port 4 different port வேணும். ஒரே போர்ட்ல 2 பென்ட்ரைவ் நம்ம போய் இது பண்ண பிளக் பண்ண முடியாது இல்லையா? ஸோ ஒவ்வொரு போர்ட் வேணும். 4 IO device கனெக்ட் பண்ண போறேன். லைக் I'm going to connect printer, I'm going to connect my pen drive, I'm going to connect my speakers, எது வேணா வச்சுக்கோ. இதெல்லாம் கனெக்ட் பண்ற அப்படின்னா தனித்தனியா நமக்கு போர்ட் வேணும். அப்பதான் நம்ம அதுக்குள்ள பிளக் இன் பண்ண முடியும். ஓகே, ஃபைன். So now my point is, what about this isolated IO? What we are going to see under this isolated IO கேட்டீங்கன்னா, see your data line and the address line. Your data line and the address line are common. எப்படி common னு சொல்றீங்கன்னா, because memory is also connected to the same data and the address line. All the IO devices, see IO port 1, port 2 and port 3. All the IO devices are also connected to the same data line and the address line. They are also connected to the same data and the address line. Is it clear for you? So அதனால தான் நான் என்னன்னு சொல்றேன், it is a common, it is common data line and common address line. அப்புறம் ஏன் isolated, why the name isolated comes in அப்படின்னு கேட்டேன்னா, because isolated ஏன் here we are going to use separate line. The isolated IO you are going to use separate lines, separate control lines. And the controller ரெண்டு இருக்கு. So I'll have read control line and write control line. Read and write control lines. Okay. So I'm going to have separate read and separate write control lines. Fine. Now look at the diagram. See, this is the read control line and the write control line only for memory. See, read and write control lines. Read and write control lines. This read control line will read the data from the CPU. This write control line will write the data into the memory. Is it clear? So you have separate read and write control lines. This is only for memory. This is only for memory. And here, what about here? See, I have IO read and I have IO write. This is IO read and IO write. See, this IO read and IO write is connected to CPU. கண்டிப்பா CPU கூட எல்லாமே கனெக்ட் ஆயிருக்கும். Okay. And it is connected to IO device 1, connected to input output device 2. It is connected to input output device number 2. So both the IOs. அப்ப இங்க read and write எப்படி கண்ணா இருக்கு? Read and write control lines are separate. Your data line is common and your address line is common. And that is being used by all the devices, by your CPU, memory, IO. எல்லாருமே they are using the, இங்க நான் பாயிண்ட் வைக்கிறேன் பாரு, they are using the same data line. Your CPU, your main memory, your CPU is also using the same. Your IO ports are also using the same data line and the address line. All are using the data and the address line. But why the name isolate comes? Because we are going to use separate read and write control line. One for memory and one for IO. அப்ப அது என்ன சொல்லணும்? This is your read memory and write memory. And another one is called read IO and write IO. So you have separate control lines. அப்ப isolated ஏதாவது ஒன்று தனியா இருக்கும். இங்க control lines separate இருக்கு. But data and address are common. இது இன்னும் உனக்கு கிளியரா புரியணும்னா I'll give an working example. I'll tell you with an example. Right. So here, isolated IO. Okay, next we'll see memory mapped IO. In that I'll show you with an example also. Yeah, here, look at here. This is a separate architecture for memory mapped IO. First in the question, you have to write an explanation. What is isolated, what is memory mapped, and the first slide na kamchalya, you have to write down all the explanation. And for every IO, you have to you have to draw the architecture diagram. Okay. So here you have memory mapped IO. In this memory mapped IO, see, all are common. Memory mapped, isolated word illa. Isolated word irundha mattumda thaniya irukkum orthu. Memory mapped in vanduduna all are common. You are going to use a common bus. The architecture is called as what we are going to use. We are going to use a common bus, okay, between your IO and memory. I am going to use a common bus. What is a bus? Bus is nothing but group of communication lines. Bus is nothing but group of communication lines, and I'm going to use a common bus. Okay, so common bus abdina, I'm going to use common data line, common address line, and common control line. My control line is also common. See, look at the diagram. See, this is the data line. Okay, this is the address line. Okay, this is my read control line. நான் தனியா யூஸ் பண்ணல. I have used the common line. See, all the read and write control lines. All are common. All are common. எப்படி மேம் காமன் சொல்றீங்க? See, look here. I'll use the highlighter. See, your data line, address line, read and write control line is used by the memory. The same data line, address line, read line, and write line is used by the CPU. The same data, address, read, and write is used by your interface for IO devices. Data, address, read, and write control line is used by second device. The same data, address, read, and write control line that is used by the third interface. Did you got it? So what they are coming to say? What they are coming to say? That is all the lines are common. All are common. The lines are common here. That is called common bus. There is no separate. Isolated word வந்தாதான் separate வரும். Memory mapped அப்படின்னா memory கூட map ஆயிருக்கு. That is memory வந்து memory and IO are sharing things னு அர்த்தம். Memory and IO. Both the devices are sharing everything between each other. தனித்தனியா வச்சுக்காம everything they are sharing. They are sharing the data line. They are sharing the address line. They are also sharing the control lines. Read and write control line. So address வச்சு பிரிச்சுக்கும். Whether it is for memory or whether it is for IO அப்படிங்கறத எப்படி கண்டுபிடிக்குமா? If they share common read and write lines. Now, the question here is, the question of doubt over here is, நாம் இப்ப read பண்ணும். If CPU wants to read the data from the memory, it will place the data in the same line. அப்போ அது கன்ஃபியூஷன் வராதா? எந்த இடத்துல இருந்து ஏன்னா ரீட் லைன் வந்து இட் இஸ் காமன் நோ. ஸோ அந்த டேட்டா வந்து ரெண்டு பேரும் தானே ரீட் பண்ணுவாங்க. That is, my memory will also read the same data. My IO devices will also read the same data. Isn't it? So both the devices will read the same data. Then how come it has been distinguished? Here, the address is being divided. See, if the address, see here, below they have given this. And in the question of doubt, kandipa ellathukkume irukum. Like here, the address. This is the address space for memory. This is the address space. Address space enga start agudhu? It starts from 1000 to 2500 வரைக்கும் அந்த அட்ரஸ் எல்லாம் மெமரிக்குன்னு பிரிச்சிடும். And 2501 இருந்து 3500 வரைக்கும் this is an address for IO devices. புரியுதாக்கண்ணா? So here, see, listen. If I have address space, this is my address space. This is my main memory. Okay. And my starting address is 1000. And the ending address is 3500. The starting address is 1000 and the ending address is 3500. Okay. So first 2500 வரைக்கும் இருக்கிற address வந்து this is my memory addresses. This is used by memory until 2500. After 2500, say 2501 இருந்து 3500 வரைக்கும் the addresses will be used by IO. This is called sharing the address. This is called memory mapped. Memory கூட போய் சேர்ந்துக்கிறது. So this is called memory mapped IO. Memory mapped IO na memory and IO are mapped to each other. They are sharing the common address space. That is nothing but they are dividing the addresses. Or first half நீ வச்சுக்கோ, second half நான் வச்சுக்கிறேன்னு சொல்லி the address space will be divided. So you can avoid, literally you can avoid the confusion also. While the machine reads the data, while the CPU reads the data, or sorry, sees the address. If it is below 2500, it comes to know, okay, I have to read the data from the memory in தெரிஞ்சுக்கும். If it is above 2500, then the CPU will recognize that I have to read the data from the IO devices. This is how the address is being differentiated. This is how the address is being differentiated. Is it clear or not? Yes? Can you understand? Any doubt in this?
No
Why
doubt,
nobody is responding? Okay, ma. So please listen to the class. These are all very, very important concepts. Okay. Yes. So we are dividing the address space. First half will be used by the memory and the second half of the address will be used by the IO devices. இப்போ புரியுதாக்கண்ணா? memory mapped IO க்கு isolated IO க்கு என்ன டிஃபரன்ஸ்னு? Isolated IO ல either you can have a separate bus தனியா இருக்கும் or at least you have a separate control line. Control lines will be separate. But here in memory mapped IO, all are common. Your data bus, your address bus and your control lines. All are shared between memory and IO devices. All are shared between memory and IO devices. Fine. Now we'll see this with an example. If an example is given, I think it will be easy for you to understand practically also. So you can write the theory by yourself. Once you know, you can draw the architecture by yourself. எல்லா 4 கோடு போட்டு ஷேரிங்கா இல்ல தனித்தனியா இருந்தா தனியா லைன்ஸ் போடணும், ஷேரிங்னா எல்லாத்துக்கும் கோடு எழுத்து விடணும், அவ்வளவுதான் ஆர்கிடெக்சர். Now see, look at this, same memory mapped IO. With an example I have given this for your understanding. See, now here the address space of main memory is between 1000 to 2500, as I already told you. And what is the address space for IO? It is from 2501 to 3500. Okay, so this is the address space for IO devices. Okay, now I need to send the data. Okay, I need to send the data. What is the data? 5800 is the data which I wish to send. And what is the address that is passed? 2750. Kana, what is the address? It is 2000. Kana, if it is 2750, then to whom the CPU is going to communicate? If the address is 2750 abdina, to whom the CPU is going to communicate? To the memory or to the IO?
IO, ma'am.
Yes, the CPU is going to communicate with the IO devices. Because the address of IO devices only, it is beyond 2500. So 2750, it is greater than 2500. So that address space is completely occupied by your IO devices. So with that address only, the CPU comes to know. So other பொறுத்து எந்த device activate ஆகுமோ அது activate ஆயிடும், enable பண்ணிடும். Memory will be disabled because அது மெமரிக்கு அதுக்கு சம்மந்தம் இல்லை, அந்த அட்ரஸ் ஸ்பேஸ்க்கு மெமரிக்கு சம்மந்தம் இல்லை. So now the CPU either can read or write. அது நம்ம அதை பத்தி பார்க்கவே இல்லை. Just this is the data. If the CPU wants to write, it is also okay. So now the CPU wants to write the data to the IO. எப்படி மேம் IO கண்டுபிடிச்சீங்க? With the help of this address, I found out that the CPU wants to write the data to the IO device. Okay, அப்போ அதுக்கப்புறம் அந்த இன்டர்ஃபேஸ் பார்த்து எந்த IO டிவைஸோ அதை மட்டும் ஆக்டிவேட் பண்ணி விடும். அதெல்லாம் நம்ம முதல்லயே பார்த்துருக்கோம். Okay, so this is how. Suppose if I send the data, if I send the address like instead of 2750, if I send the address as 2450, if I send the address as 2450, which is below 2500, which is below 2500. So automatically now the CPU is going to write the data into the main memory. Now the CPU is going to write into the main memory. That time main memory will be activated. So புரியுதா எப்படி காமன் பஸ் யூஸ் பண்ணா எப்படி வந்து டிஃபரன்ஷியேட் பண்றாங்கன்னு? There is no sort of confusion. There is no issues over here. Common bus use பண்றதுனால address resolution அது இது பிரச்சனை வருமானா? No. The address has been resolved correctly. கரெக்டா டிவைட் பண்ணிருக்கோம். அந்த அட்ரஸ் வச்சு அதுக்கான CPU will recognize whether it is for main memory or whether it is for IO devices. ஈஸியா வந்து மெஷினால என்ன பண்ண முடியும்? டிஸ்டிங்விஷ் பண்ண முடியும். Is it clear? So this is about your memory mapped IO. So again, I have clearly explained you about isolated IO versus memory mapped IO. Kana, in isolated IO, that is your data bus and the address bus is common. Okay, your data and address bus is common. But in memory mapped IO, all are common. Data bus, address bus, control bus, all are common. Okay, that is the difference. And see here, in isolated, either you can use common bus. Many computers they use common bus, but separate read and write control lines will be there. Or the bus say வந்து separate ஆக இருக்கும். You have separate memory and IO address spaces. Okay, but in memory mapped IO, you have a single set of read and write control line. There is no separating a word வராது memory mapல. You have only a single set of read and write. Both your memory and IO will share the address space. There is no specific input or output instruction specific IO memory can varaadu. Okay, there is no specific instructions. Okay, all the instructions will be common for both memory and IO. Instructions will be common for both memory and IO. Specific IO device or instructions, CPU, memory or instructions, everything will be common. Okay, that's it. So that's all about isolated versus memory mapped IO. Kana, this is very, very important question. Do anybody have any doubt in this? You can ask me. Is doubt irukka? Puriyama irukka? Isolated IO, memory mapped IO. Doubts for anybody else? Yes or no?
No, ma'am.
Okay, I think only one student is keep on responding. What about others? All are after having a great lunch. I think you people are feeling very sleepy. Are you sleeping or listening? All others. Only one or two students are keep on replying. What about others? So, அப்போ question கேட்டாதான் தெரியும் இல்லையா? Whether you are physically present and you are listening to the class or not. Okay. Last 10 minutes, I'll ask you the questions. Yeah. Now we'll continue. So the next one is example of I/O interface. This architecture is other important. Third unit, all the questions are very important. Either a big combined, they'll be asking in 16 marks, or divide 5 marks. All the questions are important. Okay. So this is another pin diagram, which shows the example of I/O interface. Very, very important architecture, important pin diagram. Okay, they'll ask you to draw the pin diagram of I/O interface in Keta. You have to draw this only. If they simply ask you to draw the architecture of I/O interface, first class I/O interface architecture. If they ask you to draw the pin diagram, you have to draw this only. Or if I ask you to write about the example of I/O interface, then also you have to draw this diagram. There is a confusion varum. In the question, the answer time because all are interlinked. Okay. So everything is interlinked with each other. Every concept has been interlinked. So you have to differentiate. You have to differentiate everything, and then only you can understand that you can write the correct concept under the correct heading. Fine. So regarding this example of I/O interface. So here, yeah. See, Kana. So here I have an internal bus. See, I'll highlight it for you. See, this is the bus. Actually, this is the bus. You all know what is a bus. Okay, it is a group of communication lines. Yes, that is an internal bus. Okay, so and the bus is bidirectional. Your data and the bus line, you have data bus, address bus, and control bus. Which is commonly called as internal bus. Okay. Now, internal bus, data, it will get stored in the buffer only. So the bus will maintain a separate buffer, which is called bus buffers. Buffer is nothing but it is a temporary storage area. So data the buffer until CPU kulla podrukko illa memory kulla podno illa IO kulla podno enga vena nee ipo eduthu poi register la store panni vechuko. But na data bus la place பண்ணனும்னா அங்க இடத்துல எனக்கு ஒரு temporary ஒரு storage area வேணும் இல்லையா? That is called my buffer. Bus is called bus buffer. Yeah. And this bus buffer is connected to one bidirectional data bus. Why it is called bidirectional? Data bus either you can place the data that has to be read, or you can place the data that has to be written. So either you can read or you can write. So rendu direction I have to enable. Okay, so it is a bidirectional data bus. Bidirectional data bus. Okay. So bus pati ellame over. Bus pati ellame over. Now, that is, we are going to connect CPU with IO device. Apply ஒரு காமனா ஒரு diagram போட்டிருக்கோம் இல்லையா? அத clear picture ஆ manufacturing ஓட சொல்லிருக்காங்க. See, initially I have shown this. இதோட block diagram சொல்ற பாருங்க. Here, sorry. So here you have CPU, and here you have IO device. Okay, this is the block diagram. Adoda complete architecture da this one. CPU, and here it is your IO device. And you know that CPU cannot directly communicate with IO devices. So enna venu? We need an interface in between. We need an interface. Isn't it? We need an interface in between what? CPU and IO, we need an interface. So with the help of this interface, they'll communicate with each other. And this is called the internal bus. In the line Verdulakana, this is called the internal bus. And this line is represented here also as the internal bus. This has been represented as an internal bus. Okay. So either the block diagram, other the complete pin diagram that is given below. Yes, it's clear up. Okay, so here I in this bus, connected. This is, and it is connected to interfaces. Before getting into IO device, we need an interface. In the interface also, I told you that there are registers, internal registers will be there. And interface kulla, it is a hardware device. அதுக்குள்ளேயும் registers வச்சிருக்கும். So எடுக்கிற டேட்டா டெம்பரரியா ஸ்டோர் பண்ணி வச்சுட்டு அதுக்கப்புறம் தான் ஐஓ டிவைஸ்க்கு அனுப்பும். ஓகே, ஸோ யுவர் இன்டர்ஃபேஸ் வில் ஆல்சோ கண்டெக்ட் சர்டன் ரெஜிஸ்டர்ஸ். ஓகே, ஸோ திஸ் இஸ் போர்ட் ஏ ரெஜிஸ்டர், போர்ட் பி, யூ ஹேவ் கண்ட்ரோல் ரெஜிஸ்டர், யூ ஹேவ் ஸ்டேட்டஸ் ரெஜிஸ்டர். அதெல்லாம் உனக்கு என்னன்னு தெரியும். கண்ட்ரோல், it is used to inform. Okay, it is used to activate the reference. Status register, status is used to check the status condition of the IO devices. So for everything you have register. Na anthapla temporary status okay na, it will return 1. Status is not okay na, it will return 0. Appo edavadhu or value return பண்ணுது இல்லையா, so you have to store the value. So value store பண்ணனும்னா we need a register. Register na நான் என்ன முதல்ல சொல்லிருக்கேன். Okay, so we need a register. It is a storage area. Register is a storage area. Okay, fine. And so in the side எல்லாமே நம்ம பார்த்துட்டோம். So between CPU and IO devices, in between there are address lines, control lines, data lines. In that the data line is bidirectional, and you have control register, you have status register, and for address you have to mention port A and port B registers will be there, and all the registers are connected to IO devices. All the registers are connected to IO device. Fine. And here in the side of CPU side la varalam. In the CPU side la, this is the pin diagram. This is very very important. CS. CS stands for chip select. நம்ம flip flop எப்படி clock இருக்கோ அதே மாதிரி in this diagram I have CS. CS stands for chip select. If this particular CS is enabled, if chip select enable இருந்தா மட்டும்தான் இந்த circuit full activate ஆகும். If the particular chip is enabled, இந்த chip enable இருந்தா மட்டும்தான் this circuit will work. If the chip is disabled அப்படின்னா this circuit will not work. Enabled அப்படின்னா CS should be equal to 1. If chip select is equal to 1, it means the circuit will work. The circuit is in active condition. It is working condition. இது வேணா சொல்லலாம். Suppose if the chip select is equal to 0, 0 அப்படின்னா the circuit itself is deactivated. Nothing works. That none. அவ்வளவுதான். ஒண்ணுமே ஐடியலா இருக்கும் வச்சுக்கோ. ஐடியலா இருக்கு. Okay, fine. That's about chip select. And you have to select the registers. எந்த ரெஜிஸ்டர்ல இருந்து you are going to read the data or write the data, whatever it is, we need a register. You know, that is a memory actually, where we are storing the data. That is called register. Register is nothing but group of flip-flops. That's register na paathirukkom. I can have 8-bit register, 16-bit registers, 32-bit registers. Adu na sollirken. So register is a group of flip-flop. A flip-flop can store only a single bit of data. Appo 8-bit register na evlo bit store panna mudiyum? 8 bits. 16-bit register la I can store 16 bits. If it is 32-bit register, I can store 32 bits. Okay, so this is how the size of the register varies according to the capacity of the machine, and whether if you are going to read the data or write. Read பண்றோம்னா இந்த line enable ஆகும். If you are going to write அப்படின்னா this particular pin will be enabled. Read na RD. RD stands for read and WR stands for write. These are the control lines. Read and write control lines. So if the CPU is going to read the data, it will activate this particular chip. அந்த சிப்பை ஆக்டிவேட் பண்ணி விடும். If the CPU is going to write the data அப்படின்னா this particular chip will be activated. So this is the pin diagram. இதெல்லாமே ஃபுல்லா ஹார்ட்வேர் சர்க்யூட்ஸ். சரியா, how the circuit is being designed inside. நான் சும்மா ஜென்ரலா சொல்லிட்டேன். CPU IO-னா நடுவுல ஒரு இன்டர்ஃபேஸ் இருக்கும், இங்க வாங்கி அங்க போடுறோம் அப்படிங்கிற மாதிரி ஜென்ரலா பார்ப்போம். பட் இது வந்து they have given a detailed picture. They have given the detailed picture. The same diagram is there in your book also. You can refer the same because this is very important. Okay. So now come to the truth table, because for every chip diagram you will be having a truth table. Yes. So in this truth table again I would like to mention that, see, if CS is 0, I told you the whole circuit is disabled. That is called high impedance state. Impedance வந்துட்டு எதுவுமே நடக்காம அது பாட்டுக்கு இருக்குன்னு அர்த்தம். Okay, that is high impedance state. இல்லைன்னா அது எப்படி சொல்லலாம், லைக் நம்ம மொபைல் வந்துட்டு ஓவர்லோட் பண்றோம்னா ஹேங் ஆகி நிக்குது அப்படின்னு நின்றும். Anything, your mobile will not respond. That is like that you can have. So that is what high impedance here. And when that particular state will come up in data, when your CS is 0, when the value of CS is 0. See, in all the other cases your chip select is 1. In all the other cases the chip select is 1. Fine. So இது same தான் நம்ம யூசுவலா flip flop போடுற மாதிரியே தான். 0 0 0 1 1 0 1 1. All the 4 combinations are given here. Because 2 bits, 2 bits அப்படின்னா automatically 2 square, automatically you will be having only 4 combinations. அதுக்கு மேல வரக்கு சான்ஸே இல்லை. So 0 பாஸ் பண்ணுச்சு அப்படின்னா port A register will be selected. If 01 is passed, port B register will be selected. 10 pass பண்ணா control register select ஆகும். 11 pass பண்ணா status register select ஆகும். So this is how you communicate with the help of this inputs. இப்படிதான் CPU வந்து எல்லா registers கூடயும் communicate பண்ணி அது தேவையான இன்ஃபர்மேஷனும் அனுப்பும். Okay, if the CPU wants to send some control signals in the A, so it has to select என்னது? It has to select the control register. If it wants to select the control register, it has to pass 10 RS1 register select the register. எந்தெந்த register select பண்ணும்? RS1 is 1, RS0 is 0. So 1 and 0. So இதுல தான் வந்துட்டு you can pass all the controls. Okay, in this only you can pass all the controls. See, so RS1 is equal to 1 and RS0 equal to 0. 1, 0. Now which register is selected? Your control register is selected. So if I pass 1, 0, the control register will be selected. If I pass 1, 1, RS0 and RS1 both are 1, 1 அப்படின்னா status register will be selected. Okay, if I pass 0, 0, both RS0 and both are 0, 0, here port A will be selected. If it is 0, 1, here port B will be selected. Okay, this is how by passing the input signals, the CPU will select the appropriate register. Yes, this is how by selecting the input signals, your CPU will, by passing the input signal, your CPU will select the appropriate signals. Is it clear? So any doubt in this pin diagram? Do you want me to repeat? Because it is very important. Do anybody have doubt in this? Shall I repeat this or shall we move to the next one?
Can you repeat it, ma'am?
Okay, Kana. See, okay. So now what we are going to do, we are going to communicate between CPU and the IO device. Yes, we are going to, I'll rub everything beforehand. Yeah. And also I'll zoom the picture. Okay. Fine. So, see, listen. So now what I'm going to do, we are going to communicate between CPU and the IO device. We are going to communicate between CPU and IO device. நான் சொல்ல parallel highlight பண்ணிட்டே வரேன், listen பண்ணிட்டே வா. ஏதாவது இடத்துல உனக்கு புரியலனா please stop there and ask me. Okay, fine. So we are going to communicate between CPU and IO device. Between CPU and IO devices, I have a bus communication. There is a bus line that is called internal bus. Your internal bus consists of your data line, address line, and control lines. Data line, address line, and control line. Okay. In that, your data you have for storing all the data. நீ இந்த பஸ் வழியா அனுப்புற எல்லா டேட்டாவையும் டெம்பரரியா ஸ்டோர் பண்றதுக்கு I have a bus buffer for storing the data. Okay. What are the data that is passed through the bus? For storing the data, we have bus buffer. And this bus buffer should be bidirectional. That is another important point. This should be bidirectional because அந்த data நீ post பண்ற. So data வந்து எந்த சைடு வேணாலும் நான் என்ன பண்ணலாம், ரீட் பண்ணணும், ரைட் பண்ணணும்னா it should be bidirectional. Unidirectional இருந்தா either you can read the data or you can write it. ஒரு ஆபரேஷன் தான் பண்ண முடியும். So definitely your data bus should be bidirectional. Both CPU கூட communicate பண்ற மாதிரி இருக்கணும், IO கூட communicate பண்ற மாதிரி இருக்கும். It should be bidirectional. One way-வா இருக்கக்கூடாது. Okay, fine. So data bus பத்தி பார்த்தாச்சு. Next, what about your control lines? Or first அடுத்தது வந்து address line வச்சுக்கலாம். So address line na based on the addresses, the appropriate IO devices will be selected. அது உனக்கு தெரியும். Because as I mentioned you before that நம்ம கம்ப்யூட்டர் கூட எந்த மெஷின் கனெக்ட் ஆனாலும் அதுக்குன்னு அட்ரஸ் அசைன் ஆயிடும். எந்த பெரிஃபரல்ஸ் கனெக்ட் ஆனாலும் அண்ட் செப்பரேட் அட்ரஸ் வில் பி அசைன் டு தெம் ஆன்லைன். ஓகே, ஆன்லைன்ல செப்பரேட்டான அட்ரஸ் அசைன் ஆயிடும். ஸோ இஃப் ஐ வாண்ட் டு செலக்ட் பிரிண்டர் அப்படின்னா ஐ நீட் டு கிவ் தட் அப்ரோப்ரியேட் அட்ரஸ். If I want to select scanner அப்படின்னா I need to give that appropriate address. if I want to select any DVD, அதோட address நான் pass பண்ணணும். So that is about your address line. So for enabling the correct addresses, correctana addresses select பண்ணணும் to communicate with the IO devices. So I can pass the IO data. Okay. So in that case, if I want to enable port A, that is first IO device select பண்ணணும்னா I have to select port A register. If I want to select the second IO device, I need to enable port B register. I need to enable port B register. Okay. So this is how, with the help of the address, you can select the appropriate IO devices. ஏதாவது ஒரு IO device address மூலமா select பண்ணலாம். And the port A, port B ங்கிறது interface தான் கண்ணா. Don't confuse. Okay. This is an interface only. Right. And you have next one. Next is you need to have a control. You need to have a control register, which is another important thing. Because your CPU has full control over the IO devices. Your CPU தான் inform பண்ணும். அதுக்கிட்ட தான் control இருக்கு. நான் அதுதான் சொல்லும். நீ என்ன பண்ணணும்? The CPU will always inform what the IO devices has to do. எதை எப்ப பண்ணணும்? When you have to do? What you have to do? Everything will be informed by the CPU to the IO device. Okay, அதான் control. இப்போ வந்து நம்ம சொல்றோம் இல்லையா, students control இருக்கணும். So students control அப்படின்னா என்ன அர்த்தம்? Because whatever the teacher has been informing, whatever the teacher is saying, the student has to follow it. அதுதான் control commands. Similarly, here also the CPU will have the control over all the IO devices. Okay, அது மாதிரி ஞாபகம் வச்சுக்கோ. So the CPU has to inform the IO device what to do and when to do regarding the task. Okay, so that is what about control register. So if the CPU wants to pass certain commands to the IO device, then the control register வழியா தான் pass பண்ண முடியும். So it has to enable the control register. அப்ப அது வழியா தான் it can pass any information to the IO device. And the last one again, it is your status register. So the status, I already told you, it always gets the status of the IO device. See, in the lines கவனிச்சீங்கன்னா உங்களுக்கு நல்லா தெரியும், your data bus is bidirectional, your address bus is also bidirectional. ஏன்னா address வந்து அதுவும் ரிசீவ் பண்ணணும், CPU-க்கும் தெரியணும். So that is also bidirectional. Your control is unidirectional. The control line is unidirectional. ஏன்கனா because CPU can control IO, but IO cannot control CPU. அந்த இடத்துல நான் bidirectional போட முடியாது, isn't it? அதான் your control line will be unidirectional. And the status is also unidirectional. Status அதே மாதிரி தான். The peripheral, your IO device's status can be given to the CPU, but the CPU status வந்து IO device கணும்னு அவசியம் இல்லை. CPU தான் head, அதான் center core. Okay, that is the DIN over here. So CPU தான் IO device கண்ட்ரோல் பண்ண முடியும். IO device ஓட ஸ்டேட்டஸ் தான் CPU கெட் பண்ணும். CPU பத்தின ஸ்டேட்டஸ் எல்லாம் IO device தெரியப்படுத்தணும்னு அவசியமே கிடையாது. So your control registers, your control line and the status line are unidirectional, but your data line and the address lines are bidirectional. This even a single arrow mark makes sense over here in this diagram. சும்மா நம்ம இஷ்டத்துக்கெல்லாம் போட முடியாது. Everything makes sense. Okay, everything makes sense in the diagram. Right. And finally, coming to the registers, finally coming to the pin diagram. In the pin diagram, what are all the important things? What are all the things you have to note down here? You have a chip select. You have a chip select. Only if CS is equal to 1, the circuit is active. Only if CS is equal to 1, the circuit is active at all the time. If CS is equal to 0, now the circuit is not in active state. So your data bus is in high impedance state. That is, in the data bus, if CS is equal to 0, your data bus is in high impedance state. Fine. Now, if the CPU wants to select the IO registers, ஏதாவது ஒரு IO device select பண்ணணும் அப்படின்னா, it has to pass only through RS1 and RS0. RS stands for register select. R stands for register and S stands for select. So எந்த ரெஜிஸ்டரை செலக்ட் பண்ண போறோம், தட் இஸ் எந்த IO டிவைஸ், எந்த ரெஜிஸ்டர் அப்படின்னா இந்த இடத்துல வந்துட்டு எந்த இன்டர்ஃபேஸ் செலக்ட் பண்ண போறோம், எந்த இன்டர்ஃபேஸ் செலக்ட் பண்ண போறோம், அப்படி அந்த இன்டர்ஃபேஸ் செலக்ட் ஆனா அது கூட இருக்க IO டிவைஸ் கரெக்ட் ஆகுதுன்னு அர்த்தம். ஓகே, so which register are you going to select, that is which IO device are you going to select. So for this I have two things, ஏன்னா because I need two things இருந்தது அப்படின்னா, because here we have 4 registers. Okay, so 4 registers இருக்கும்போது கண்டிப்பா I need 2 inputs, அப்பதான் 2 square 4 combination வரும். That is the reason why I go for 2 registers. இங்க 8 இருந்தது அப்படின்னா then I have to go for 3 registers. இதுவும் மாறும் according to the size of your computer. Again the registers will vary. Okay, so here I am going to use 2 registers. Okay, So in the two registers, what are all the input I can give? I can give 0, 0, 0, 1, 1, 0, 1, 1. These are all the inputs that I can give. Two inputs na ipdidan kudukka mudiyum. This is common நம்ம எல்லாத்துலயும் இதான் பார்க்கிறோம். 0, 0, 0, 1, 1, 0 and 1, 1. So according to the register inputs, the appropriate devices will be selected. அதனால அந்த லைன்ஸ் மேல எழுதிட்டேன். உங்களுக்கு டவுட் வரக்கூடாதுன்னா. So if the CPU selects 0, 0 அப்படின்னா port A register will be selected. If the CPU passes 0, 1, 0, 1 இங்க RS1 இதுல. Okay. So 0, 0 na first one, 0, 1. இந்த இடத்துல pass பண்ணா இந்த இடத்துல இந்த device select ஆகும். Your port B register will be selected. If the CPU passes 1, 0, the control register will be selected. If the CPU passes 1, 1, the status register will be selected. இன்னும் clear சொல்லணும்னா, now my CPU wants to, okay, my CPU wants to give control to the IO device. IO devices ஏதாவது ஒரு command pass பண்ணணும்னு நினைக்குது. Okay. In that case, in the register select, CPU என்ன value pass பண்ணும்? In this register select, the CPU should pass the value of 1, 0. RS1 is 1, RS0, 0. இப்படி பாஸ் பண்ணுச்சு அப்படின்னா எந்த ரெஜிஸ்டர் செலக்ட் ஆகும்? கண்ட்ரோல் ரெஜிஸ்டர் செலக்ட் ஆகும். அட் தட் டைம் the CPU என்ன கண்ட்ரோல் பாஸ் பண்ணுதோ அது IO டிவைஸ்க்கு போய் சேர்ந்துரும். ஓகே, now இல்ல இப்போ வந்து நான் என்னோட கம்ப்யூட்டர் வந்து ஒரு பிரிண்டர் கூட கனெக்ட் பண்ணியிருக்கேன். Okay, now I have connected my computer to the printer. Now I have to ensure that whether the printer is in on condition. Printer onல இருக்கா, printer working stateல இருக்கா, இந்த மாதிரி அதோட ஸ்டேட்டஸை நான் செக் பண்ணணும்னு நினைக்கிறேன். So now the CPU has to select which register? Status register. If the CPU wants to select the status register அப்படின்னா என்ன வேல்யூ பாஸ் பண்ணும்? It will pass RS1 equal to 1 and RS0 equal to 1. So if it passes 1, 1, appropriately the status register will get selected and accordingly அந்த IO device, அந்த corresponding IO device ஓட status எல்லாம் யாருக்கு ரிப்போர்ட் பண்ணிடுவோம்? CPU-க்கு ரிப்போர்ட் பண்ணிடுவோம். அதனால தான் it will get the status from the printer and it will report the status to the CPU. And it will report the status to the CPU. Okay, is it clear? Still, and register select is over. Then, if I want to read the data, if the CPU wants to read the data, then the read line will be enabled. If the CPU wants to write the data, then the write line will be enabled. That is about read and write. Okay, still anybody have any doubt in this architecture? This is very, very important pin diagram. இன்னும் யாருக்கு நான் டவுட் இருக்கு? Still, if you want me to repeat நாலும் no issues. I'll repeat once again for you. Shall I repeat or shall we move further? Why nobody is responding? All are listening or simply sitting?
Go further, ma'am.
Yes? I can't hear you.
We can move on to next, ma'am.
Okay, Kana. Okay, Balasurya. What about others? Kingsley, are you there in the meet? Kingsley?
Yes, ma'am.
Can you hear me? Are you listening?
Yes, ma'am.
Then have you understood? Yes or no? Why no response? Prakash? Prakash, are you in the meet? Prakash, can you hear me?
Ma'am.
Prakash, என்ன நடத்துறேன் புரியுதா? ஹெட்டிங் அது எழுதி வச்சிருக்கியா?
எழுதியிருக்கேன் மேம்.
கவனிக்கிறியா கிளாஸ்?
பார்க்குறேங்க மேம்.
பார்க்குறியா கவனிக்கிறியா?
மேம் கவனிக்கிறேங்க மேம்.
Okay. Okay then. So if you have any doubts now, you can ask me. In the next class, I'm going to ask you the question in the complete picture. So please do revise and come. By tomorrow, I'll be asking you the question. You people have to explain me. Now, yaar explain panna solrano, they should be ready with this diagram. Okay, so everyone, please take the screenshot of this. ஸோ உன்னோட மொபைலில் இருக்கிற ஸ்க்ரீனை ப்ரெசென்ட் பண்ண சொன்னால் மொபைலே ஸ்க்ரீன்ஷாட் இருக்கும், அதை அப்படியே நீ ஓப்பன் பண்ணி யூ கேன் ஸ்டார்ட் ப்ரெசென்டிங். நான் என்னோட ஸ்க்ரீன் ஓப்பன் பண்ண போகிறது இல்லை, நான் யார் நேம் கூப்பிட்றனோ யூ ஹாவ் டு ஓப்பன் த ஸ்க்ரீன் அண்ட் யூ ஹாவ் டு எக்ஸ்பிளைன் எவ்ரி திங் விச் எவர் ஐம் ஆஸ்கிங் யூ. ஓகே, ஸோ பி ரெடி வித் யுவர் ப்ரிப்பரேஷன்ஸ் பை டுமாரோ. திஸ் பர்டிகுலர் ஆர்கிடெக்சர் எலோன் ஐம் ஆஸ்கிங். நான் மற்ற எதுவுமே சொல்லல, ஒன்லி திஸ் பர்டிகுலர் ஆர்கிடெக்சர். அதான் திரும்ப திரும்ப கேட்குறேன். இஃப் யூ ஹேவ் எனி டவுட்ஸ்னா ஆஸ்க் மீ நவ் இட்செல்ஃப். நாளைக்கு நான் கேட்கும்போது நான் எனக்கு இது புரியல அது புரியலன்னு ஸ்மார்ட்டாக பதில் சொல்லக்கூடாது. ஓகே ஃபைன். ஸோ தேர் இஸ் நோ டவுட்ஸ் அப்படின்னா ஓகே வில் வைண்ட் அப் த செஷன். த நெக்ஸ்ட் வந்து யூ வில் ஜாயின் இன் த EVS லிங்க். ஓகே, EVS லிங்க் ஐ வில் சென்ட் இட் டு யூ. ப்ளீஸ் ஜாயின் இன் தட். ஓகே, கேன் வி வைண்ட் அப்?
Ma'am, for third unit, when we will receive the recordings, ma'am?
Then once I complete it, I'll give it to you, ma'am. Still, 2 topics are there. After completing the 2 topics, I'll send it everyone. Okay.
Okay, ma'am.
Yeah.
Thank you, ma'am.
Okay, Kana. Yeah. Thanks, ma'am. We'll wind up the session. Thank you.
Thank you.
Thank you, ma'am.
Thank you, ma'am.
Thank you, ma'am.
Yeah,
Thank you, ma'am.
Thank you.
Thank you, ma'am.
Yeah, thank you, ma'am.